do this one. I don't know if you see my slide.
Yes, we see it.
Okay.
Yes, we see it.
But my problem is the slide is not.
You need to scroll down, maybe. I mean, we can see for now. So.
Okay, let us start. So, hello everyone. Thank you so much to give me floor, Bimbin. Thank you so much also for the to assist on this session concerning the energy citizenship project organized by Energy Citizens for Inclusive Decarbonization Academy, led by Bimbin Pierce. So my project concerning the recovery of urban solid waste for electricity production, present by myself. So my name is Hasiniaina from Madagascar. I have a background in economics and energy science. Okay, so let us go in the first slide. So this is the plan that I want to present for today. So I will present the context concerning the solid waste management in general. I will present my country, Madagascar, the problem statement, the solution, the objective, and I will present the prototype that we will create on this project, and to present the future plan and our teams. The context, as we say, generally, the electricity is a crucial resource for modern life and economics development. That means that we cannot do anything without electricity. For example, if we take the education, so that increase the level of education if we don't have electricity. That means there are in the link between the economics and the electricity. As we see in this figure, that shows us the lack of the access of the electricity in the world. In the green color, we see the Middle East, so 19 millions or 1.5% don't have access of electricity. In the Latin America, 24 million, that means 1.9% don't have access of electricity. In the yellow color present in their country, so 306 million don't have access of electricity. And if we see in the country of Africa, the north of Africa is inferior than the sub-Saharan Africa. So in the north of Africa, we see 1 million or 0.08% don't have access of electricity. And in the sub-Saharan Africa, 599 million or 47.6% don't have electricity. And in Africa, that is why we have a mind to create on this project. So what is the challenge to meeting the electricity demand due to various factors, such as the aid cost? For example, the price of the kilowatt in my country, Madagascar, is around 581 ariary, so equivalent 0.132 dollars. And then the limited infrastructure and the environmental concern. So this is the main principal problem in Africa, especially in my country. concerning my country, the island Madagascar. So the capital of Madagascar is Antananarivo. So there are 26 million population, and Antananarivo generated about 5,000 tons of municipal solid waste, of which 261,186 tons in 2006, and we will predicate in 2023, so it will be increased twice. And who is affected in this project? So the population who lives in the urban areas, and who is the responsible on this situation. So the governmental, there is no intervention of the governmental to put the right policy out to reduce the municipal solid waste. And then the citizens or population don't follow the instruction by the governmental, and there is a low level to contribute for the private enterprise. So the problem statement, there are three problems. One problem is in many urban areas, solid waste is not properly managed, leading to environmental, health, and social issues. And then the landfills are often overburdened, causing the pollution, emissions of methane, and risk of the contamination. The last problem is the incineration. Among of the different types of the recovery of the solid waste management, the incineration can be expensive and also generate the air pollution and toxic residues. So what is the solution? The solution is to find a more sustainable and efficient ways to deal with urban solid waste. We also generating energy, as we see in this picture. So we will focus on the gas for to use in the manage and electricity. The objective on our project is to recover the energy from urban solid waste through the anaerobic digestion, a process that produced biogas, a mixture of methane and the carbon dioxide that can be used as a fuel for electric generation. And then this is our prototypes of the urban solid waste biogas system. The first step is the waste collection and the pre-treatment system. So the system would include the waste collection containers, such as bins or bags, and the sorting process to remove an organic waste. And this is the new challenge, new system that we will implement in our country, the sorting process. And the waste will then be shredded and mixed to create the homogeneous feedstocks of the anaerobic digester. And the second step is the anaerobic digester. So the digester will be a closed vessel where the organic waste will be broken down by microorganisms in the absence of oxygen. This process will produce a biogas, which is composed mainly of methane and carbon dioxide. The digester would be designed to optimize the condition for the microorganism to thrive, such as a temperature, pH, or like that. And concerning the gas storage or utilization system, so the biogas will be stored in the separate containers and could be used as a fuel for the generator under the electricity generation system. The gas would need to be purified to remove any impurities or contaminants, such as hydrogen sulfide or moisture. And the electricity generated could be used for local or grid-connected application, such as powering homes or businesses or like that. And to finalize, the prototypes will be tested and optimized based on the local waste characteristics, the climate, and the energy demand. The result will be used to refine the design and assess the feasibility of scaling up the system to the location. So what are our future plan? There are two. The short-term plan. The short-term plan, there are three points that we want to implement concerning the design and build commercial scale systems. So based on the success of the prototypes, we will work to design and build a commercial scale systems that can be implemented in urban area with 8 levels of organic waste. And concerning the environmental impact, as the project expands, we will closely monitor the environmental impact of the system, including the greenhouse gas emission, water use, waste generation. And we will work to minimize the negative impact and maximize the positive benefits for local community and the environment. Concerning the economic or social impact, we will also evaluate the economics and social impact of the project, including the job creation, the revenue generation, and the energy access. So we will work to ensure that the benefits of the system are distributed fairly and equitably across the community. Concerning the long-term plan, so the first of all is to expand the multiple location, as we know that our location is in the urban area. So once we have successfully deployed the commercial scale system in one location, so we will look to expand the urban areas. We will prioritize the location where there is a demand for electricity and the 8 level of organic waste that is currently not being utilized. And concerning the system, we will continue to refine and improve the system based on feedback from our partner and user, but from now we have no partner on this project. And finally, we will explore the potential application for the biogas, such as cooking fuel, exploitation fuel, or industrial process. So we will work to identify the most promising opportunities and develop partnership with relevant stakeholders to explore these options further. So this is our team that we work on these projects. We are 3 from now. So thank you so much for your attention. So you can contact me if you want directly by email or by my phone. Thank you so much.
Thank you so much, Hasiniaina. And as is the case with, great job, as is the case with all of our presenters, if